Alright, so in the differentiation video series, we looked at how to form differential equations. We're now going to actually try and solve these differential equations by integration. So a first order differential equation is in the form where dy by dx is equal to something, something, something. And it's going to be in terms of two variables, x and y. Or it doesn't have to be x and y, it can be like p or t. The fact is there's going to be two variables. And so what we're going to do is move all the letters of the same letters to one side and all the other letters to the other side. So in this case, what we have is dy by dx is equal to cos squared y plus cos 2x cos squared y. So as you can see, we have y terms and we have some x terms. So as I said before, we're going to move all the y terms to the y side and all the x terms to the x side. This also includes the dy and the dx because they are y and x terms. So I'm going to leave the dy this side. I'm going to move all the y terms to the left-hand side. So the way I can do that is just maybe we can factorize it, saying it's cos squared, and then in brackets we have 1 plus cos 2x, like this. Now I can now divide it by cos squared y and leave the 1 plus cos 2x on the right-hand side. So I can say I have 1 over cos squared y dy is equal to 1 plus cos 2x, and then dx, think about like a fraction, so you multiply to the right hand side dx, and now I'm just going to integrate both sides like this. So the very first step is you should be separating the variables, moving y's to the left hand side, x's to the right hand side. Important things to note is you can only multiply and divide to each side. You don't want a plus or minus. So sometimes you might see this cos squared y and you might think, oh, I can just subtract it and therefore bring it to the left hand side. You don't want to be doing that. So you only want to be multiplying, dividing, as we said before. Right, after we've done this, now what we have to do is now we just integrate each side separately, just thinking about the y's on their own and the x's on their own. So the left-hand side, 1 over cos y squared y is the same as sec squared y is equal to 1 plus cos 2x plus dx. Sec squared y integrated is just tan y, and that's equal to x plus 1 over 2 sine 2x. Right, when we integrate, remember there's always a constant plus c. This plus c always goes on the right-hand side with the x terms. Okay, so you don't need plus c on the left-hand side and the right-hand side. You only need it in one side. In this case, the right-hand side. And this here is the solution for the differential equation. And it's known as a general solution because we do not know what the c value is. Okay, so in the exam, they might ask you to find a general equation or the general solution, in which case we can just leave it like this and leave it as plus c. However, sometimes they might ask you for a particular solution, and a particular solution is when they are giving you some boundary conditions as shown in this question here. So they've said that y is pi over 4 and x is pi over 4 as well. So in this case, that means we can actually find the c value. So we just have to plug it in. So we can say that tan pi over 4 is equal to pi over 4 plus 1 over 2 sine 2 pi over 4 says pi over 2 plus c. This is 1, this is pi over 4 plus sine 90 is 1, so it's plus 1 over 2 plus c. So c is 1 over 2 minus pi over 4. So therefore, the final solution will be tan y is equal to x plus half sine 2x plus 1 over 2 minus pi over 4. And now, because we found the c, we have actually now found the particular solution. Okay, so be careful of what they want you to find. If they give you some boundary conditions, i.e. an x and y value, then they want you to find the particular solution. Right, let's just try one more. So let's try this question here. So for this kind of stuff, you're going to have to know all the different integration methods, all the different integration for standard functions like sine, cos, tan, and so on and so on. So first things first, they're asking us to express this in partial fractions. Once again, if you are just unsure about partial fractions, maybe go back to the video where we looked at partial fractions. So we have 2x minus 1, and we have x minus 1, 2x minus 3, and I want to split this up into a over x minus 1 plus b over 2x minus 3. We now combine them again, so a 2x minus 3 plus b x minus 1. And because the denominator is the same, we can just equate that to the numerator on the left-hand side, We're trying to find a and b, so we have to let x equal to something. In this case, x is 1 to get rid of the b term. So therefore, we have 2 times 1 minus 1 is equal to a times 2 times 1 minus 3. This is 1, this is minus a, so a is negative 1. To get rid of the a term, we let x equal to 3 over 2. So we have 2 times 3 over 2 minus 1 is equal to b times 3 over 2 minus 1. So we get, this is 3, 2 is equal to half b. So b is equal to 4, like this. So I can rewrite the partial fraction as minus 1 over x minus 1 plus 4 over 2x minus 3. Now this is very common, they ask you to do this before solving the differential equation because we're going to need this for later on. Right, in part B, it says find the general solution, meaning we can leave as plus c, for the differential equation, this one here. So we have 2x minus 3, x minus 1, dy by dx is equal to 2x minus 1y. So we have some x terms, we have some y terms, right? So first things first, we want to separate them into x and y. So I want to bring the y to the left-hand side, x's to the right-hand side. As we know before, we can't plus or add or minus, so we have to multiply or divide. So I'll divide by 1 over y, and then I'll divide to the right-hand side, 2x minus 3, x minus 1, and I'll multiply my dx like this. And then I'm just going to integrate each side separately. What you should realize is actually the left-hand side is simple to integrate. The right-hand side is the same equation as the initial partial fractions. So I can rewrite it as this form. That is why they asked you to find this form in part A. This is very common in the exam. So we're going to have 1 over y dy is equal to the integral of minus 1 over x minus 1 plus 4 over 2x minus 3 dx. Well, this is now ln y. This is now minus ln x minus 1. And this is 2 ln 2x minus 3 plus c. So this will be the general solution. One thing to note is when we have found the general solution, if every single term is an ln term in your general solution, then rather than c, what we can do is replace it with ln k. Okay, so that's a hint or a tip that you should replace it with ln k rather than c if every single term is an ln term. In this general solution, if we have like one term which is not ln term, so for example like an x, then we can't change it to ln k, we have to just leave it as plus c. Right, in part C there says find the particular solution when y is 10 at x is 2. So now we found the general solution in part B, but in part C, when x is 2, y is 10. So we can now plug it in to find this ln k in this case. So we have ln y is ln 10 is equal to minus ln 2 minus 1 plus 2 ln 4 minus 3 plus ln k. Right, ln is actually a log term, right? So we can actually try and replace or combine them together. So I can say that ln 10 is equal to ln 4 minus 3 squared over 2 minus 1 plus times by k, right? So what we can say is this is now ln 10 is equal to ln inside here we have k times 1 squared over 1. So ln 10 is ln k. So therefore k is equal to 10. So if I was to write my final equation out, then I can say that, well, ln y is equal to minus ln x minus 1 plus 2 ln 2x minus 3 plus ln 10. And because they're all ln terms, as I said before, we can combine them. So ln y is equal to ln, and then we're going to have 2x minus 3 to the power of 2 times by 10 divided by x minus 1. And the ln's can cancel, you're left with y is equal to 10 times 2x minus 3 squared over x minus 1. So this would be my final particular solution. So for differential equations, make sure you divide and multiply so you get y is on one side, x is on the other side. Integrate them separately using all the integration methods that we've learned before, and then you find the plus c if they're asking you to find the particular solution.